Let's start on network applications. Examples of network applications we know include email, web browsing, messaging, remote login, file sharing, network gaming, video streaming, voice over IP, social networking, search, and so on. Remember we learned about core and edge of the networks and about end systems or hosts at the edge of the networks. Network applications run on end systems and communicate over the network. They might have client-server or peer-to-peer architectures. They might be developed in different programming languages and environments, but what is common among them is that they run on the end systems and they communicate over the network. In the client-server application architecture, one of the end systems, which is called the server, is always on, so that it can receive requests from the clients and respond to them. It needs to have a permanent known address so clients know how to contact it when they need services. IP address, a permanent one, is used for this purpose, which we will discuss in the network layer discussions. With the number of requests from different clients increase, one end system may not be able to respond to all of their requests. In this situation, data centers running virtual servers over many physical resources could be utilized to respond to the increased requests. Many of popular online services, like search or different social media and e-commerce websites, run on the data centers. In the client-server model, clients initiate the request for the service to the server. They communicate with the server knowing its address. Clients do not need to be always on. They also do not need to have a permanent IP address. In this architecture, clients do not directly communicate with each other. When you open your laptop in school and connect to the Wi-Fi network and do a Google search, your browser sending a search request to Google is a client of a network application. And Google responding to your request, running in data centers, is the server. In peer-to-peer architecture, there is no always-on server. Peers request service from each other and provide service to each other in return. As the new peers are added in the system, they come in with their service demands as well as their resources and service capacity. Therefore, this helps the peer-to-peer system to scale to keep the service with addition of the new peers into the system. The peer-to-peer architecture does not have an always-on server with known address to respond to the requests. Peers come and go, and they have different IP addresses in their intermittent connections. Therefore, a complexity in peer-to-peer systems is about managing the peers and managing the service as the peers come and go.